Hi everyone, my name's Daniel, and I'm here to tell you that the world we live in is far stranger and more miraculous than any movie you've ever seen. The laws of nature are far stranger than the magic in Harry Potter. And that feeling is something I want to share with you through this podcast. So, the first point I want to start with is actually a question. If you had to pick one piece of knowledge, one fact to safeguard against time, to pass down to future generations, what would it be? I'll give you a second to think about this. Alright. Well, for me at least, and I'm not the first one to think this, but I think it's a pretty great one, is I would pass down the idea of atoms. From the Greek word atomos, meaning uncuttable. And at a later date, we'll actually get to the validity of that word. But for now, we can think of them as being uncuttable. See, the thing is, we know now that the stuff the universe is made out of, that you and I, our homes, the air we breathe, the food we eat, it's all made out of these little tiny particles. And we've given these tiny particles a name. We call them atoms. And see, we also know that they have this strange quality that they actually attract each other over, when they're a short distance apart. But they actually repel when they're forced to be squeezed, when they're squeezed closely together. Isn't that already quite strange? They attract when they're a little distance away, but if you force them together, they start to push against each other. The same way magnets, the two north poles of a magnet will repel when you force them to get too close. And we also know that they're constantly moving. They're constantly vibrating and jiggling. They're never still. They've always got this little energy to them that they're always moving and vibrating. And we actually have a name for this motion, this vibration. It's what we know as heat. So, take your hands right now, for example. Rub your hands together. You feel the heat that's being generated by you rubbing your hands together. That's because you've forced the atoms in the skin of your hand against each other. And you've forced them, by rubbing your hands together, you've made them vibrate quicker. And then you feel those vibrations as heat. See how already this little nugget of information already contains within a wealth of understanding about a fundamental part of the universe, of reality. I think it's great. I think it's nuts. A few sentences and we've tapped into something that's been kept secret from us for thousands and thousands of years. So let's double down on the craziness now, though. I said there were these, small little things, but how small are they actually? Well, take an apple. A regular apple, anyone, a Granny Smith perhaps. There are as many atoms inside that apple as there are apples that you could fit inside the entire Earth. Think about that. There are as many atoms inside that apple as there are apples you could fit inside the Earth. Or here's another example. Take a sheet of paper. If you have one nearby, the effect of this will be double. So, take a sheet of paper. There are 1 million atoms across the thickness of that paper. Or actually, if you don't have a sheet of paper, take one of your hairs. About the thickness of one of your hairs is about 1 million atoms. It's pretty nuts. So we know more about these atoms, these things. We know actually that there's two main parts to them. There's the positively charged middle bit, which we call a nucleus. And orbiting it is this negatively charged bit. It's a negatively charged particle. It doesn't matter what it's called. It's just a negatively charged part orbiting it and a positively charged part in the middle. And you don't even need to get too caught up on the positive and negative thing. it doesn't matter what they're called. We could call the middle one, the central bit, negative, and the outer part positive, and everything, the entire universe would still function the same. In fact, we could call the middle bit top and the outer bit bottom, or the middle bit left and the outer bit right. As long as they have the quality that they're oppositely charged or oppositely oriented, which means they would attract in the world we live in, that's all that matters. But these are just names. So we said that this negatively charged bit is orbiting the middle bit, the nucleus. So how far is this negative part from the nucleus then? Well, if we blew the nucleus, this middle part, up to the size of, say, a basketball, then the part orbiting it would be over 3 kilometers away. Or to use an example, a real-life example, if the middle part was, say, the MCG, then the part orbiting it would actually be in Brisbane. And all that stuff between, that's just empty space. So look at your hand right now, given that fact. And that's actually, you may know that already. But look at your hand and consider now that what you're looking at is mainly empty space, given our understanding of the universe. What's more is that we also know that over 90% of the mass of the stuff in this atom is actually localized inside that middle part. So it would be inside the MCG. It doesn't leave much to the outer part, and yet that outer part is absolutely crucial to everything you see in the world. And we'll get to that at a later date. There's enough here to keep us entertained, I think. But there's a beautiful symmetry in that fact, I think, a symmetry of nature, in that we know that the sun also contains over 90% of all the mass in our solar system. If you were to add up all the masses of all the planets, they would be nothing compared to how massive the sun actually is. So it's interesting, you have this negative part orbiting the center of the atom, and you have the planets orbiting the sun, and they both have pretty much the same proportion of mass. It's all localized in that central part. So this model of the atom, with this negatively charged bit orbiting around the middle, that was actually only proposed in 1913. It's a little over 100 years ago. It tells you a lot about how far we've come, in the last 100 years. Your great-grandparents or great-great-grandparents would never have had access to know this secret, this hidden fact about the universe, about reality. We don't even... A lot of us take it for granted about this beautiful secret that only now has just been revealed. Something that's so intrinsic about who we are and the world that we live in. So I'll leave you to think about this. But I'd ask you that as you go about your day, today or tomorrow, if it's your evening now, that you remember these things. You remember these truths about atoms, about their behavior, about their traits, about the space between, within them, within you, for that matter. And then I ask that you hold them in your mind as you look out at the world. You might find that it contains a little more magic than you remember. Until next time, look after yourselves.